Hey friends, we are starting another casual live stream of coding this Celtic Knotwork algorithm using using Cuddle's code components. How are you all doing? We are working with this paper that we started the last session and trying to code this algorithm up that will make these knotwork patterns. And last time we got up to here, and then after this, somebody asked me, could you make an activity like this that would be appropriate for fourth graders? And I ended up making this printable template. Looks like that. And it's pretty cool. You basically draw in the break lines that we did last time. So these are the break lines, and then the break lines determine where the knots are going to go, sort of where the braids are going to go, and then they get over and under appropriately. But this printable sort of does a lot of the work for you, so to speak. So just to give an example, this is where we were at the end of the last session. And if we try to do that one, essentially, I'll just draw in. So it's like a 3x2 grid. And then there is a break line here and here. And then what ends up happening is you trace around the break lines. Let's see if I can do this right. So that would go like that, and then up through here. Down through there, coming around this way, and then reconnecting there. And the interesting thing, I think, is that where the over and under is completely predetermined by where these gray lines already are. Which is a surprising result to me. I would think that, it would depend on which way the band was snaking around to determine where you'd need to put the over and under such that they always alternate, right? Because you always want to go under and then over and then under and then over. So that's completely predetermined by the grid, I think, is a pretty interesting result. And by doing this exercise on paper like this, I think I got a much better intuition of how these patterns work, so to speak. And I think that'll help when we try to finish up the code for this today. So one thing I want to point out is that so we're doing this in Cuddle using a code component, and I just want to point out that Cuddle's not just about writing code. You can use it as a totally normal design program where you just have shapes and you resize them and you draw paths and all that. But code is a thing that you can do in Cuddle. And so I think it's what we're trying to do is make a design program that's easy to get started and lets you do the basic things really well. Change your dimensions, snap things, draw what you need to draw in order to cut your shapes out. But while it's very simple to use, we also want to have a high ceiling, so to speak, meaning that there are lots of things that you can do, including write code to generate your shapes. And so that's just the feature that I'll be using today. So if you're not a programmer, this might be, I suppose, a less interesting live stream. But if you are a programmer or you're sort of interested in JavaScript or how programs can generate shapes algorithmically, then this might be interesting. So that's why I'm live streaming it. All right. So we were here last time, and we had done a thing where you can input in the break lines using this sort of ASCII art. Hi, Kim. Thanks for saying hey on the chat. So you can input in the ASCII art like this that puts in your break lines, and then we made this what Andrew Glassner calls the skeleton, which the skeleton goes around avoiding the break lines, and then the idea is that once we have the skeleton, we want to eventually get to here, and that's sort of what we're trying to do today. So we had this ASCII art. We'd figured out how to draw the skeleton around based on what these like vertical and horizontal lines are doing. And so yeah, next step. So based on, this printable, like, I think we're really close actually. Something we have to do is right now the skeleton just takes these shortcuts. It just needs to put in this center point, and we need to do the over and under correctly. And because the over and under is predetermined by the grid, it should be relatively easy to get that part. So first thing I want to try to do is make put a center point there. And I think I can just add in an additional center point here. Yep. Okay. So that's already looking a lot better. We're going to need to, whenever there's one that goes from a corner to the center to a side, it's supposed to be a curve there. Those are going to be where the curves are. So we'll add that in later. And we're going to have to do the over-under part. Which to do first? I feel like the over-under might be the harder one, so maybe I'll try to do that one first. So I think what we need to do is basically if one of our... We have this P1 and P2, which are sort of where it's coming from. If either P1 or P2 is at a corner, we need to potentially inset it a bit so that it goes over or under or if it's going under, then we need to move it, I think. So let's just sort of test that hypothesis. I think maybe I'll have a function asking if something is a corner, and that's if p dot x is so if the x part is 0 or 1, so p dot x equals 0 or p dot x equals 1, is y part of a corner, p dot y equals 0 or p dot y equals 1. And then if the x is 0 or 1 and the y is 0 or 1, then we've got ourselves a corner. So let's say if is corner p1, then need to check if it should go under, and if it does go under, then we would move it by a certain amount. We would move it towards the center. So each one of these is like a grid square, and we need to move the corner to some other place, which is, I think we're going to need a parameter for that. Let's call it, say, spacing. Might change the name of that. So let's see, I want to move this by spacing. I think I just want to have a function that does that. Move corner by spacing, I'll call it that. We'll see. Okay, so so basically I need to move it away from the 1 or 0 points. Okay, so now we're moving sort of all the P1s. Let's just, I guess, do the same thing for P2. Just to see if this is sort of working. Oops, that should be P2. Okay. So yeah, so now it's finding all the ones that are going into a corner and then moving them out by this sort of arbitrary amount. All right, so then next I think I want to figure out, some of them should not be going under, some of them should be going over, in which case I'm not going to move the corner point by the spacing amount. And I guess specifically, like, so what are the grid squares? I think the grid squares are like this and like this. I'm pretty sure that's like the size, or no, do I have that wrong? Are we looking at, no, that's right. So like here, for example, is a grid square. And so basically we just need to know whether the grid is even or odd, like whether it would be black or white on a checkerboard. And then we can use that to, if it's say black on the checkerboard, then we want to make sure that I'll draw some more of them. If it's black on the checkerboard, we want to make sure that the lower left or upper right is offset. And if it's white on the checkerboard, then we want to make sure that the upper left or lower right is offset. Okay. So so we know X and Y are where we are on the grid. And then forest kids say hi to cats. Yeah, we have one cat here. Hey, Jaxie. Forest kids say hi to you. Jaxie's been enjoying working in the office with me these days. Okay, back to trying to figure this out. All right, so X and Y determine where we are on the grid. So X and Y are going to determine like whether we're on a black or a white square of the checkerboard. I think I want to have just sort of an overarching function that can figure out whether it's like black or white, so to speak, and move the corners if so. So the hardest part of that is coming up with a name for that function. I guess it's sort of like underweave. Like it'll move the point if it should. And let's say that takes a P and an X and a Y. And maybe I'll write a comment. If the braid needs to go under. We'll clean up all this stuff later. Let's just keep moving forward. Okay, so first we'll figure out if the thing is even or not, which I think is just X plus Y % 2 equals 0. And I'm sort of seeing the same logic down here. I wonder if these will eventually be able to merge in a way that will make the code cleaner. We'll keep going with this, but that's a suspicion I have. Okay. So I believe we can sort of arbitrarily choose whether we're going to go over and under as long as the other one goes the opposite way. So I'm going to say if it is even, then we're going to care about just pick one, whether we're in the like upper left and lower right. So how do we figure that out? If it's even and if p dot x okay, I think I know. So maybe we can just say if p dot x plus p dot y is even. If p dot x plus p dot y % 2. So if that's even, then we'll underweave. And I think I'm also going to say if not, I only want to do this with corners for sure. So if it's not a corner, just return exit early out of this function. I think I'm going to call this grid is even to clarify. So if grid is even and then the other thing is even, then we'll underweave. So move corner by spacing. And if the grid is odd, and the point is odd, meaning it's going this way, then we'll underweave. And who knows if this is going to work. Underweave E1 by X and Y. Didn't seem to work. Okay, so what are we doing? Oh, P, X, and Y. I'm just going to put a console log here to see that we are getting to this point. Okay, so we are getting past this line. And so here are some I wonder why these are 1 and 2. That doesn't seem right to me. This P variable, I feel like I thought those were always like 0, 1s and stuff, or like between 0 and 1. So I'm confused why I feel like is this happening to the same point? And then this is getting okay, so I think what I'm going to do is I wonder if this is ever getting called. So it looks like that's never getting called. Okay. So P.x and P.y are 1s and 0s. So I feel like this kind of thing should be happening. So I'm getting here. These are all odd. Those are all even. I wonder if I just switch these numbers, if something better will happen. Ah, nope, that's not right. That's getting all of them. I'm going to get rid of some of these just to make it more clear where things could possibly be going wrong. All right. So I believe this is the 0, 0 point for that. This is 0, 1. I think this is 0, 2. And then x 1, 0. I might have things wrong. Maybe it's like that or something. Is it underweaving in both conditions, even and odd? Yeah, I think that's the issue. It's like I can either get it to underweave all the time or none of the time by changing these things, and that doesn't seem right. I guess I can just try like bashing the code and like sort of see if anything can happen. Like if I just get rid of that condition or something. No. Well, that's not quite right because it needs to go over on that one. Yeah, I really thought that basically like the x and y and this p.x and p.y, which are either 0 or 1, like I feel like those are the only things you need to know if it should be doing an underweave. So it's like here. You know what? I think I might be wrong, or slightly wrong. So like this is how the paper starts talking about the underweaves. Diagonals for even rows, it does this. So basically, for even rows, the right side is underweaved, and for odd rows, the left side is underweaved. I think that's probably a better way of doing it. So if it's even and p.x equals 1, then we'll underweave. And if it's odd and p.x equals 0, then we'll underweave. That's still not right. Let's get rid of this just to see. Okay, so if it's even, I kind of want to color this so that I can see like the checkerboard. I might do that sort of for funsies. Okay, so if p.x plus p.y percent 2, I think I need to wrap these in parens, is 0, then color the checkerboard square So we'll do output dot push. Let's make a rectangle. So I think it's just a default rectangle, and then we'll transform, or rather move, we're going to move the rectangle to be at, these shouldn't be P, this should just be X and Y. I'm pretty sure I'm going to have to subtract a half, but let's just do that. Okay, I'm getting these rectangles. They're not getting drawn because I think they don't have like a fill or a stroke or anything. Fill, color. And this is going to be like a transparent black, if I got that right. Okay, and then yeah, I need to, I guess, add a half. Okay. So I've got the even squares colored here, and yeah, I think the even squares, maybe the way it is that the even squares want to always be undered, and then the odd squares always want to be over? No, because they're going to be switching here and here. Because I want this one to be under. Well, let's just like sort of try these out as we're talking them through. So if I just always do the even ones, then you get this. But that's not right, because we want this one to be over and then this one to be under. So I feel like maybe we really care. And maybe I will try to draw on this grid. So then, wish I had a highlighter, but so these are the black squares. So it's not that every black square is the same. It's like on this row, we want to under the lower left. On this one, we want to under the upper left. So it goes like lower left, upper left, lower left, upper left. And then on the next one, it's lower right, upper right, lower right, upper right. Okay. So let's write that out a little bit. First row, we want to do lower left. Maybe I'll call it southwest. We'll do southwest, and then northwest, southwest, northwest, dot, dot, dot. And then the second row, we'll do southeast, northeast, southeast, northeast, dot, 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 and then dot, dot, dot. So that's sort of the pattern we're going to try to do. So maybe we'll just sort of brute force this out. So the row is the y. So if the row is like first row, or like if it's one way, then if x%2 is 0, then we care about the southwest. If p dot x equals 0, and p dot y equals 1, move corner by spacing. And then otherwise, now we're in this condition. Something like that. Okay, and then we just have to get the next one. So otherwise, so now we're in the second row condition. Here we care about the southeast. So that's 1 and 1. And then the other side, we care about the northeast. So that's y is 0 and x is 1. This is looking right. So surely there must be a very simple way of writing this, but we've managed to do it by sort of brute forcing through all of the different conditions that could happen. I would like to look at this and try to figure out if there's a better way to do it, but I think in the interest of trying to like forge ahead, I will leave this code as it is and then come back to it. To do, surely there's a better way to do this, but it works for now. Okay. All right, so now we have this like underweave thing that we're doing, and that's awesome. And now we've got this, and then I want to add a curve here. I just want to round this corner for all these ones where it's going that way, because that's part of what gives these designs their charm. So I think to do that, I'm going to round it here. So I've made this path, which has 3 points, like here, here, and here, for example. So we need to see, like, is it one where there's a corner and a non-corner? So if is corner P1, that's what we called it, right? Is corner. If is corner P1 and not is corner P2, it's going to be another side of that. Or is corner P2 and not is corner P1. Then we'll round it. And to do that, we can call round corners the modifier. Round corners. And I think what we have to do, round corners is going to return some new geometry. So I think we're going to say G is equal to, I want to round corners. This is my input, which is this path that we're making. And then this is my parameters. I think if I just, yeah, here we go. So now that's getting rounded, and I must be doing something wrong that, we're underweaving and then it's not recognizing it as a corner anymore. So I need to figure this out up here. So should round corners is going to be this condition. There we go. Okay, so now it's rounding the corners, and these are the parameters we would pass in, and let's see, what does round corners take? It takes a parameter called radius, which can be any of these, some number. You can also make it infinity, and then it will like round it till it can't round it anymore. So maybe I'll try that, but we'll probably end up playing with the look of it, or maybe this will be a parameter or something. Ooh. I think that looks sort of cool. Yeah. Maybe that'll end up being a parameter, I think. I'll call it rounding. So now I've got a parameter to control the rounding. I think that's nice to be able to control. Likewise for spacing, which is nice. And then I feel like we just need to, instead of making these hairline, let's make them thick, and then should look pretty good. So I'm assigning a stroke here. I need to look at my scripting reference to see, how do you make a stroke that's not hairline? Constructor, okay. Color hairline will be false, and then width will be some number. Okay, false, and some number. Cool. Okay, I'm going to comment out the checkerboard. And let's make this a parameter. Okay, so we've got that. We've got this spacing thing. I'll probably reparameterize these, but sort of good for now, just to sort of see what it would be like to be able to play with these parameters. And then we should be able to add in more of these these break lines too, and that seems to be working still. So how about if we add a symmetric one down there? Oops. And maybe one like that. Yeah, all right. I think it's working. I think I want to reparameterize this whole thing also, because it's kind of difficult to work with these things, but oh, my grid size has to be bigger. There we go. Yeah, I think it's working. So I would say I'm going to call it for this live stream, because I think that we have sort of like, it is working. There's lots of code cleanup that has to be done, but that's, I think, less interesting to watch. So I will publish what I have. In fact, I'll do that now. Paste it in the chat. And I would say that that is good for this series on coding the Celtic Knotwork pattern. I think I'm going to be cleaning this up and then publishing it as, like, I don't know, a template or something. But I'll leave this version as it is for reference. So thanks everyone for watching, and I'll see you later. Bye.